Hey everybody, thank you for joining us. I just typed a little message in the chat box to make sure that if people are not hearing me, they can figure it out. But we'll go ahead and get started. Thank you for joining us. This is our final outreach webinar for a project that we've been working on for a year and a half. Our nickname for it is SETr. The full title, if my keyboard will let me advance the slides. Here we go. Our full title is Marsh Surface Tracking Sea Level Change, Developing Tools and Visualizations for NERRS Sentinel Site Data. This has been about a year and a half long project with a large project team and lots of collaborators. And today we're going to show off the outreach products that we've made. First, I'm going to start by telling you a little bit about the project and about how we got here, and then we're going to go through the outreach outputs that we've produced and let you see them and give you some ideas on how to use them moving forward. The overall goal for this project was really to make it easier for reserve staff to work with surface elevation table data. We were hoping that by creating the tools that we're creating, they could also be useful for people outside the NERRS. This was a Science Collaborative-funded grant, and as you probably know, the Science Collaborative really loves to see end user involvement. They love to see projects driven by end user needs, and this one absolutely was. If you're not with the NERRS, we're a network of 29 national estuarine research reserves all across the country. As of writing the proposal, 26 reserves had SETs installed, and 15 of them ended up contributing data to this project. The way that we were trying to make it easier to work with data was by developing some standardized data formatting and quality control and analysis tools. But the reason I think you're all here is we also wanted to help everyone communicate about this data too. This got started at a NERRS annual meeting a few years ago. My stewardship coordinator here at Grand Bay had wanted to start working up set data. We had had our sets installed for a little over 5 years, and I was really getting into using a programming language called R to make a lot of data visualizations and graphs. And somehow those got showed off in a joint RC-SC session, research coordinators and stewardship coordinators at an annual meeting, and they said, we want to make some of those with our data too. Then later in that same meeting, in a Gulf regional session, we were talking about Tote Workshops, teachers on the estuary. And again, our reserve, our stewardship coordinator and education coordinator have been working together to use set data in Tote Workshops. And someone else commented, it sure would be nice to use some of our actual data. And the seed had already been planted to write a proposal to make some visualizations and graphics. And when that was said, it seemed like such an obvious way to combine efforts and create products that could be used not just by technical people, but then take those products and work with our education and outreach staff to turn them into something that could be used for their audiences too. It was also really good timing because the Sentinel Site program had been around for several years, and it's been long enough now that most of the reserves that have sets have enough data that they want to start analyzing it. As you probably know, it can take a while to get enough data to start looking for trends. And so the timing on this all just worked out. The enthusiasm was there. We wrote a proposal to get a Science Catalyst grant, which was supposed to last a year. We got an extension, so this is our 18th month. And the project team included 6 reserves. We knew at the time that 2 more reserves were also willing to contribute data. And then 6 months into the project, we sent some of the outputs we'd already generated and said, this is what we've been able to do. If you want to send us your data, we'll do this for you too. And we got data from more reserves. So all in all, it's been 15. So the outputs that I'm going to talk to you about, most of the time spent on the project was really developing the technical products, debating the differences in vocabulary between reserves, differences in how we measure things, what might make things look different. And we kind of all came together once we coalesced around that and were able to start documenting the graphics better and talking more with our outreach folks just within the last few months to really bring it all together for outreach. What we're creating are tools to be combined with other information. These are not going to be complete lesson plans. They're not ready to go in the classroom. They can and should be adapted for your needs if you're the one using them. And they're meant for collaboration between technical and outreach staff. These outputs are going to be generated for every reserve individually. And when you're looking at graphics, you really want to say, what does this mean? And we've incorporated a lot of questions about what things mean into the outreach materials. But you're really going to want to talk to the technical staff at your reserve to answer those questions because it's different everywhere. And that's not something that I could just automate in the output. So this is really meant for you to work together and find the story that your data is telling and figure out how to communicate that to your audiences. So the output itself is a Word document. We picked this because people know how to use Word. It's being created through this R program, but what you see is going to be in Microsoft Word. So if you want to cut out any of the explanations or if you want to add interpretations, you can do that because it's just Word. You don't have to deal with any of the technical stuff in the background. So we're providing background information and figures in these documents. One other thing that I want to say is at the beginning, we sort of assumed outreach was going to be a combination of coastal training program audiences and education audiences. As it evolved, the coastal training audiences, or who I would have lumped that way, like natural resource managers, they've really been very involved in the technical parts. So this Word document has evolved more towards the education side, the teacher side, and a much less formal tone than we might use in other places. And that's on purpose. We're trying to keep the attention of teachers and educators and people that might want to learn about this. So next, I'm going to come out of PowerPoint and just walk you through an example. I just generated this morning because I had a bright idea about something to change. So as you'll see, the title is just Set Outreach Tools, and it shows the date that the report was created. So you can make these year after year, or the person running the program can make these year after year. So we provide some background on the Sentinel Site program and sets in general. And we get down to describing sort of how measurements are taken at a set. I'm assuming people on this webinar are familiar with them, so I won't get into it too much. But we do have this document to show, hey, this is what we measure, these pins sticking up above the arm, and they're a proxy for the shape of what's happening down at the surface. And so over repeated measurements over many, many, many years, you get a lot of data that we want to look at. So that's what all this wording is going into. And why? Marshes are important. We want to know if they can keep up with sea level rise. I was also asked to include a picture of actual people measuring sets. So thank you to Hudson River Reserve for this one. And then we get into the more individualized information, reserve level background and context. This particular report that I'm showing you is for us here at Grand Bay, but if your reserve was one of the ones participating in the project, you will see one with information specific to you. We pulled the local rate of sea level rise from NOAA's website, from Enlon stations. So that information is included, the rate, where it came from, what was the date range that went into it. This has been a big deal in the technical circles because long-term sea level rise might not necessarily be representative of what's happening over the short term. So we're trying to just be very clear about what was done and let people know it and what those limitations might be. Then we have some metadata tables just to tell a little bit about the setting. What type of surface elevation table is it? What's the dominant vegetation? So this is all automatically generated based on information that was provided and then how we built upon that throughout the project. Then you get down to some sampling information. For us, it's very, very similar at our sets, but some reserves have sets that have been installed for a decade longer than others. So this table just shows the first and last sample date, how many years it's been sampled, and how many times it's been sampled over that quantity of years. Some reserves sample more than once a year. We started sampling quarterly and then moved to yearly 5 years in. So that number will be different for everybody, and it's just kind of important context that we wanted to provide. And then we get into graphics. Because again, what we want to know and communicate is, how are these sets changing over time? I've gotten a lot of excellent input from educators about how to approach these graphs and how to describe them. So what we tried to do was start simple. So we're starting with just one surface elevation table and saying, all right, our x-axis is the date, so we're moving through time. Our y-axis is the change since that first reading, and I include some descriptive text in there about how we average the 36 readings per date together to get this one line. And then, oh, I need to rearrange this, I'll come back. Then we add just a linear model over the top of it, because when we generate this rate of change for a set, we're simplifying all of these measurements, and we want to simplify that down into a number, a rate of change, and that's the slope of this line. Now, something that we've really been trying to hit hard through the course of the project is, you really need to look at your data and make sure a line is appropriate. And in trying to communicate this, we decided to add in a graphic where a line is not appropriate. What you can see here is basically two chunks of time, where in this chunk of time, it sure looks like the elevation at the set is decreasing. And the earlier time looks like it could be decreasing or staying the same, or that one's a little trickier. But the really obvious thing is, something happened. Something happened in between these segments. And if you take the slope of this line and say, that's the change at this set, that's not telling you what you think it's telling you. This line is not a good descriptor of the change at this surface elevation table. So we're really trying to make sure that the technical people take a look at the graphs for all of their sets and make sure that a line is appropriate. I will say, for most of the sets that I've looked at in this project, a line is absolutely fine. But it is something that we want to communicate. So then we can change the graph a little bit. This is essentially the same thing you saw before. If you get rid of the red, it's the same. The solid blue here is that line describing the change at the set. It was dashed in an earlier graph. And what the red line represents here is the rate of sea level rise. So remember, I showed you earlier, we pulled this rate of sea level rise from NOAA, and that's just the slope of this line. And what we want to know is, are these lines parallel, or is one of them steeper than the other? What we want to see is the blue line steeper than the red line. We want the set to be gaining elevation faster than sea level is rising. So we're showing all of this with just one graph. In this graph, they're pretty parallel. We're keeping pace. Again, that's the long-term sea level rise. And then one more version where we just removed the little points, so the data is just represented by that light gray line. But then once you understand the one graph, you can throw it all together and say, here are all the surface elevation tables at our reserve. Each panel in this graph is a single surface elevation table at our reserve. The red line is the same in every single one because that's sea level rise. And then the blue line is the change at that set. So you can see in the first row, these are mostly pretty parallel. So those are chugging along about the same pace that sea level's rising. Our second row, the blue line is very flat. So that is not keeping up. And then the others, there's some variation. At our reserve, they're mostly similar. But the idea here is once you understand the single graph, put them all together and get a picture of what's happening at the whole reserve. And again, I can't interpret this as thoroughly in the actual outputs that you're going to get. So this is where you'll need to talk to the people who are taking the measurements and really understand the sets. So you're probably saying that's all well and good, graphs are fun. And actually, one of the reasons that we've gone through this go from simple to more complicated graph progression is because the education coordinators have said there's a need to teach graphs and how to understand what they're telling you. So they wanted to build these up and just start from the bottom to help increase understanding along the way. If that's not a need where you are, again, this is Word. You can just delete whatever you don't want to keep in there. It's just a picture. So this next graphic is taking the slope of all of those lines, the rate of change at each of the individual surface elevation tables, and we're just putting them on the same graph. Things are a little bit flipped here. The rate of change is actually along the x-axis. So along the right side, we have surface elevation tables gaining elevation faster than ones down here at the left. There's a vertical line for 0, and then a dark vertical line to represent that long-term rate of sea level rise. So you can see at a glance how things fall out. Slightly more than half of the surface elevation tables here have a rate of change that's higher than the rate of change of sea level rise. And then these half on the left are not keeping up. It's a bit of an oversimplification for technical audiences, but it can be really useful, especially for education. Another thing that we have tried to do is arrange the surface elevation tables in order from low marsh or lowest elevation relative to the water line, essentially, up to going uphill, upslope at the top. Not all reserves had that information to give, so they will be arranged alphabetically if that wasn't the case. But otherwise, it's going to be low elevation at the bottom, high elevation at the top. So then we can add a layer onto this graph. Because we've talked about we have 36 measurements per date, no one estimate of a rate is going to be perfect. So we add these whiskers in to represent uncertainty. For the technical minded among you, these are 95% confidence intervals. The way that I've been explaining it to the educators I work with is the wider those whiskers are, the less certain we are about that rate. So we have more uncertainty about the rate of this set than we do about the rate of this one that has narrower whiskers and a narrower confidence interval. So that's a layer that we build on and build this up. The next layer we build on, because of course science is complicated, sea level rise also has a little bit of uncertainty associated with it. It also has a 95% confidence interval. So now we're just representing that with shading. And this gives us a lot more information than we had before. There are a lot of different ways that we could actually start saying, this set is keeping up with sea level rise, or this set isn't. And yet another complication is the rate of change of sea level was calculated using a different method than the rate of change for our sets. So comparing them can be a little tricky. So what we've settled on for this project is to basically ask, do the confidence intervals overlap or not? So in these three that I'm circling right now, they are way up above sea level rise, none of the confidence intervals overlap. So we would feel pretty confident saying, yep, those are exceeding sea level rise. These three on the left, again, confidence intervals don't overlap, so we're pretty comfortable saying those are not keeping up. And then you have some that are kind of in the middle. So these are what we would say the confidence intervals are overlapping. So we could say, you know, the estimate at this one is higher than the estimate for sea level, but we're not super confident that that one is exceeding. So that's kind of the language that we're using to try to describe what you're going to see in the next few figures. Actually, in the maps, which we'll get to slightly later, there's another twist on these figures, and it's because people kept asking, can we color the points by the dominant vegetation? Because maybe a certain vegetation type, which is potentially associated with a higher elevation, is responding differently. And maybe the trends can be explained by the vegetation at a site. So we did add that in. And again, we have the entire buildup of these graphics just colored by vegetation type. And some questions that you can ask as you're working through this with teachers, with students. You can basically just ask, what are we seeing in these graphs? Are the rates of change between 0 and sea level rise? Are they greater than sea level rise? How do the vegetation communities compare? And those sorts of things that we really want to get students thinking about. And then the last of the graphics that will be in this outreach report are maps. We're going to take this information and say what's happening spatially across a reserve. I'm going to come back to this one because I didn't talk about it. But this map is comparison of the set's rate of change to sea level rise. And this follows the theme of, is it higher or lower? Do the confidence intervals overlap or not? So the arrows tell you which side of the sea level rise line the set rate is sitting on. And then if it's red or blue, the confidence intervals don't overlap. If it's gray, they overlap. It can take a little bit of time to wrap your head around, but it can also be a really nice visualization of what's happening. And I have a slide about that in a little bit. The other map that's in here is just comparing the rate of change to 0. Are the sets actually gaining elevation? Which at our site they mostly are, and mostly we're very confident that they are. All right, so let me come back to the slideshow. Here we go. Okay, now the really fun thing that you can do at your local level is pull out the stories and start combining graphics. This is a map from Narragansett Bay, and most of their sets are really not chugging along too well, but there was one of them that had a very steep rate of change, and that's here on the map. The way this was explained to me, actually, that's not a happy thing that's happening, because the marsh is becoming boggy and waterlogged, and the way my contact described it is he's kind of just expecting the marsh to fall apart any day. So there is, again, a little bit of interpretation that you have to do with the local knowledge and the people who know the sites and who know the data, because this is a problem. But seeing it on a map, you actually can have an idea spatially of where this is happening, and then start to ask other questions and put together other stories that you can communicate. So this is back to our earlier dot and whisker graph. And again, this, do confidence intervals overlap or not? And the colors that we talked about with the maps. But the next thing we want to do is summarize at larger levels and say, all right, what's happening at these different reserves? Keeping in mind that one reserve is not necessarily representative of the whole coastline or the whole state. So we will show what's happening at different reserves on a map. Just keep in mind it's one reserve, a set of surface elevation tables. So don't overinterpret. But what we're going to do, the colors mean the same thing. If it's red, it is not keeping up with sea level rise. The difference here in this pie chart is that dark red means the confidence intervals don't overlap, and light red means the confidence intervals do. So the light red and light blue on the maps, these were gray, but they were up or down arrows. So here they're just lighter colors. And then the dark blue is the sets that are exceeding sea level rise. And we're just putting them all together on a pie chart to represent how many of the sets at each reserve are in each category, essentially. So this is what it looks like when you put them all on a map across the country. A few of these have some yellow, which is not enough information. Typically, that's SETs that have not been installed and measured long enough to calculate rates. The calculation that we're doing is very, very sensitive to short time periods. So we could only calculate rates if a set had been installed for at least 4.5 years and had at least, I think it was 5 measurements that we used as the minimum. Otherwise it gets thrown in there as not enough information. So we have a national map, but we also have regional maps that you can make. And this is another area where you can combine it with other graphics. So this is the graphic that you've already seen a bunch of times today. And this is that same graphic for Mission Aransas in Texas, and the same graphic for Apalachicola over in the Florida Panhandle. You can see the scales are a little different. 0's in a different spot here for Apalachicola. It's in a different spot here for Mission Aransas because they both have sets that have negative rates of change. So again, it's just more information. How do you want to combine it? What are the stories you want to tell? And these higher level maps will be available in a national synthesis that we're putting together as part of this project as well. So you'll be able to work with some of that for additional context that you maybe haven't gotten just in the outreach document. So that was the Gulf. These are the Mid-Atlantic reserves. I don't know if I have anything to say about this, but I want you to be able to look. So this will all be available very soon. Our project period ends at the end of this month. The reserves that sent data will receive everything by the end of this month with reports already generated, including the outreach document we just went through and a technical document that goes into a lot more detail about a lot of things that we tried to simplify. If you're interested in those details, we are having another webinar on February 27th at the same time. It'll be 1 Eastern. So by the end of this month, participating reserves will have everything. All the reports and the national synthesis. And the reports and summaries will all be publicly available. Some reserves have agreed to share their data too, so that will also be available. So by the end of the month, everything will be generated. I'm not entirely sure when we're gonna figure out where it lives on the Science Collaborative website, but it shouldn't be too much past that. And another thing is these tools are part of a workflow. They're meant to be updated and regenerated as needed. So anytime that data is collected or yearly or whatever you want at your reserve, once these are sent out, they are in the reserve's hands. They are not going to be updated automatically like the swamp status reports are. They're going to be yours. We are planning to use some of these materials for a Tote Workshop here at Grand Bay this June. Again, building off of what Avery and Jonathan have already been doing and then incorporating this data, these graphics, and just trying to build. This grant, like I said, was a Science Catalyst project, so it's meant to cause more things to happen even after the project period. So the last bullet point here is a bunch of question marks because I want you all to go forth and use these in really cool ways. There has been chatter about trying to adapt the Tote Workshop that we do here at Grand Bay and make at least a Gulf-wide project out of that after we get through this one. Apply the lessons we learned and make a bigger product. So hopefully many more interesting things will happen. This has been a huge team effort. A lot of people, a lot of data, 187 surface elevation tables from 15 reserves and reserve partners. 50 plus people have been involved. I suspect that number is higher by now. Many states, many agencies. It's not just reserves that are excited about this. It's the Park Service and the Fish and Wildlife Service, because they're getting set data too. But this really seems to be the first batch of tools to visualize it and communicate it in this way. So people have really been excited. We've had a lot of calls, a lot of workshops. I called it 2.5 technical workshops because we took up half of a time period at the annual meeting. And so I really just want to thank everybody who's been involved in this. It's been a great effort with lots of enthusiasm. So just a reminder, if you have any questions, you can go ahead and type them in that group chat. If you want to be emailed when the final products are available, we will have a link and we will send that out. So follow this tiny URL to that website. It will take you to a Google form and you can just sign up for our email list. You're always welcome to email me. And I think I'm gonna call that good for content unless y'all have questions. Thank you so much for attending. I'm just gonna say I don't see any questions in the chat box. Someone did say they'd be interested in scaling up the resources from the Gulf Tote to CB NER. I don't know if you're at the one in Virginia or Maryland, or if you're talking about both, but definitely email us. Maryland, thank you. You guys made that really cool cake to illustrate a surface elevation table. If y'all don't know what I'm talking about, look on the Chesapeake Bay, Maryland Facebook page. They made a cake and there was frosting and breadsticks. They used the breadsticks as set pins and showed how you lower it down, and the texture of the frosting made them stand up to different heights. It was a really cool example. Well, thank you, everybody. I will stick around for a couple of minutes, and otherwise, I think we are all set. So thanks again for joining us. And if you have any questions, get in touch. One more question, can you share where the webinar recording will be located? It's going to be on Grand Bay NERRS YouTube page. Our admin actually set up a playlist just for this project, and the link to it was in the email with the link to this webinar. Will there be any example graphs available for education folks? Yes. You will get an entire report like we went through, an entire Microsoft Word document. And if you guys are interested, I have some PowerPoint presentations where I sort of described them the way that I've done here. So if that's what you mean, then the answer is absolutely yes, that will be available. Thank you, Kristen. Kristen just shared the link to our YouTube channel. And there's a question, isn't growing equal to sea level rise good enough? I don't know if I'm the one that should answer that question, so if someone with expertise wants to unmute themselves and chime in, feel free. What I'll say until someone else speaks up is in some places it might be, but you've got to keep in mind that what we're showing on these graphics is long-term sea level rise, and the rate of sea level rise is increasing. So even if it's keeping up in these graphics and outputs, that doesn't mean it's going to keep up over the next few decades. Well, it seems to have slowed down, so I'm going to go ahead and stop recording and call it a day. Thank you, everybody, for joining in. And if you're interested in the technical stuff, remember February 27th. The link for that webinar was in the same email as the link for this one, but we'll also be sending it out again earlier that week. Thanks again. Join our email list.